Okay, let's go and start with the free body diagram. We got two forces, the tension from the unrolling, right, and the weight of the object. We have big R and little r. Little r is the inner radius, big R is the outer radius, right? So tension exerts a torque, so T times big R is equal to the torque, which is equal to I alpha, right? Our inertia is 1/2 m big R squared plus little r squared, and alpha can be written as the linear acceleration divided by big R, right? So let's rewrite that as tension times big R is equal to 1/2 m big R squared plus little r squared times A over R. Convert the R on this side, square it. Right, instead of Newton's second law, mg minus the tension is equal to ma, right? So mg minus, or the equation for the tension, so 1/2 m r squared plus little r squared times A over big R squared is equal to ma, m in every term, so we can cancel the m's. Bring it on over, so that gives us g is equal to a plus 1/2 big R squared plus little r squared times a over r squared. Now let's go bring out the a, right, because of the GCF, so g is equal to a times 1 plus, and we can go to break up the fraction too. So big R squared over 2 big R squared plus little r squared over big R squared, 2 big R squared. This becomes a constant of 3/2, and this is like 1/2 r squared over 2r squared. So we can take out a GCF of 1/2, multiplied by 2. So 2g is equal to a times 3 plus r squared over big R squared, right? And just divide by 3 plus r squared over big R squared, and that gives you our a2, right? 3 plus. Now we know with the kinematic equation, delta x is equal to v naught times t plus 1/2 at squared. There's no v naught in either case, and we're going to put this in terms of delta x because that's what we want, and time is the same in both cases. So that becomes 1 over t squared is equal to 2 times delta x over a. So a1 over 2, delta x is equal to the h terms, right? h1 has to be equal to a2 over 2 times h2, right? Or a1 over a2 is equal to the 2h1 over 2h2. 2's cancel. h1 over h2 is equal to the ratio of the accelerations. a1 is equal to, well, g, and a2 is, well, we already solved for that, 2g over 3 plus r squared over big R squared. Now, if we just divide those two, g's cancel, bring that up, that becomes 3 plus little r squared over big R squared over 2 is equal to the ratio of the heights. Or we can rewrite that since little r is equal to r in, and big R is equal to r out, right? So we substitute for the values, big R, or r in is equal to 0.044 centimeters, and big R, or r out, is equal to 12 centimeters. That would give us h1 over h2 is equal to 1.55. So h1 is 1.55 times h